Now, most algebra classes, you're going to start with solving equations. That's right. You have to have an equal sign for it to be an equation. We do not have equal signs in any of these four problems up here. So what we're dealing with is inequalities. Usually that's the second chapter. Right after you've learned to solve equations, you go right into solving inequalities. And there's really not a whole lot of differences except for a few minor details. One of which you have to be able to graph your solutions to these inequalities. You're going to isolate the variable just like you would in an equation. You've got to isolate that variable. And then once you find out what the solution is, you have to graph your solution set. And that is usually on a number line. So what you can see here is that on the left side over here, on this side of the board, I gave you two inequalities that do not have the line underneath them. Over here on this side of the board, I gave you two inequalities with that line, which means or equal to. There's a difference in our graphs when we graph our solutions. I'll get into it. We're going to go over all four of these problems. And by the end of this, you're going to be an expert at solving inequalities. So how do we do it? We treat it just like any other equation that we've ever dealt with. We have to isolate y. My goal is by the end of this, I need y to be all alone on this left side. So we need to get rid of plus 7. Remember inverse operating from chapter 1? We're going to do the exact same thing. We're going to subtract 7 from both sides. Now when that cancels out, 9 minus 7 leaves me with just 2. This inequality needs to stay the same direction that it always is. Y over negative 6, y over negative 6 comes down. Now we've got to get rid of dividing by 6 on the left side. So we have to ask ourselves, what's the inverse of dividing by 6? What's the opposite of dividing by 6? That's right, it's multiplying by 6. But in this problem, it's a negative. One of the new rules that comes into play that you do not deal with when you are dealing with equal signs is that when you have to multiply or divide to inverse operate, if you're doing it with a negative value, the sign is actually going to flip the other direction. So right here, in order to get rid of negative 6, we're doing the opposite of dividing by negative 6. We're going to multiply by negative 6. And by doing that, it just cancels that value out on the left side. If I do it on the left side, I also have to do it on the right side. So over here, I need to take 2 and multiply that by negative 6. So 2 times negative 6 is going to give me a negative 12. But remember, the rule with inequalities, if you multiply or divide by a negative to isolate a variable, you have to flip the sign. So it's pointing this direction, we need to flip it pointing the other direction, which changes what it's saying. It's no longer y is less than, like it was up here. Now it's y is greater than negative 12. Okay, so how do I graph that? Number lines are how we graph our solution sets. So you're going to notice a big difference between these two graphs when compared to these two graphs because these two have the line underneath. You'll know what the difference is in just a bit. I always tell my students to put 0 down so I know that they know where the negatives are and where the positives are in regards to a number line. So I've got my 0. Negative 12 is really the only value I want to see on the number line, so just put a negative 12 down. Since y is greater than negative 12, I'm going to do an open circle. When I say an open circle, it's just a bubble that hasn't been filled in. If I wanted to close the circle, I'd be filling that bubble in. I'll tell you why we would close it in just a little bit. For right now, just leave it open. And now we have to ask ourselves, y is greater than negative 12. So where are numbers that are greater than negative 12 on the number line? Are they to the right or are they to the left? As we move to the right on a number line, values get larger, they get bigger, okay? So y is greater than negative 12. So as long as my value that I plug into this inequality for y is larger than negative 12, at the end of this expression, my value will be less than 9. Any number to the right of negative 12 plugged in for y will make this inequality true. So this is my solution set graphed out. This is my solution with an isolated variable. Let's do the same thing down here. We got to isolate x. My goal is to get x all alone down here. I've got to get rid of minus 1. So we ask ourselves, what's the opposite of subtracting 1? Adding 1. That will cancel it on the left. Add 1. 7 plus 1 gives me the value of 8 on the right. I've got 4x being brought down. Oopsie. We're not dealing with equal signs. We're dealing with inequalities. I do that all the time. Just go back and fix it if you do the same. Okay, we're going to divide by 4. Divide by 4. Nice, neat number here. X is, do I flip the sign? We only flip the sign if we are multiplying or dividing by a negative. I'm just dividing by 4. 4 is not negative, so I do not want to flip my sign. I'm going to keep it pointing the same direction it has been for the entirety of the problem. 8 divided by 4 comes out to 2. Now I have my solution. I just got to graph it. So x is greater than 2. So how would I graph that? I draw a number line. I'm going to give 0 every single time. Positive 2 is to the right of 0, so let's just put it right about there. Again, I'm going to do an open circle at that value. Open circle, meaning I'm not filling it in. Okay, we're not including 2. X cannot be 2. X could be 2.1, X could be 2.2, X could be 6, it could be 30, it could be 55. Anything to the right of 2 is greater than 2. X is greater than 2. We now have a graph displaying every possible value that can be plugged in for X to make the original inequality true and accurate. Okay, now we go over to this side of the board. The only difference you see from these problems and these two problems is that my inequalities here have these lines underneath them. All that means is or equal to, meaning we're going to include the value that we get at the end. Here we say we can't use 2. 2 would not work over here. But 2.1, just barely to the right of 2, would work. Here, because we're saying we're equal to, whatever our solutions are, we could actually use that number as well. Okay, so let's solve this two-step by adding 4 to both sides. Plus 4 cancels. Plus 4 gives me 9. Bring down the inequality. 2v comes down, 2v. This is multiplication between 2 and v, so I'm going to use division to cancel the 2. Divide the other side by 2. Doesn't give us a nice neat value. V is greater than or equal to 9/2, also known as 4.5. So whenever I have a decimal, I encourage my students, it's not mandatory, but I encourage my students to give me 2 integers that decimal falls between on their number line. So what would that look like? If I'm going to draw my number line, I need to have a 0. Over here I would have a 4, and about there I'd have a 5. So now that I'm going to graph this out, 4.5 is the number where I want to put my dot, my circle. So I'm going to go halfway between 4 and 5. Those are my 2 integers. It's a decimal, halfway in between those 2 values. Now over here, remember these circles? I said keep them open. Keep them open. What we're going to do on this one is we're going to close it. Why are we closing the dot? We're filling it in because we're saying V has to be greater than or it can be equal to 4.5. So we want to include 4.5 as well as everything that's larger than 4.5. V is greater than or equal to 4.5. So greater than would be to the right. This is our solution. Any value to the right of 4.5 on a number line would work in this inequality here. So we could go and we could pick a number greater than 4.5, 10, right? If I throw a 10 up here, it will make this inequality true. Let's check it. What's 2 times 10? 20. 20 minus 4 gives me 16. Is 16 greater than or equal to 5? Yes, of course it is. Okay. Last but not least, we're going to get rid of this 8. It's a positive 8. We got to isolate C, so we're going to get rid of 8. Positive 8, the opposite would be minus 8. Gone. See you later. Take away 8 over here. You got a negative being subtracted, or 8 being subtracted from a negative. Be careful on problems like that. Double check them on your calculator if you're not good with adding and subtracting positive and negative values. That gives you negative 24. This symbol comes down. Oh, we better be careful here. Kids are going to make a mistake here because what do we got to do to get rid of that negative 9? We have to divide by a negative. And I just talked to you about dividing by a negative. The second you do that, you need to flip that sign. So I encourage my students, before they even cross that out, before they do anything else, the second they say, I'm dividing by a negative, flip the sign right away. Change the direction of that sign so that you don't mess that up because kids do tend to forget to do that at the end. Okay, so these cancel. We got to divide by negative 9 on the other side. Divide by negative 9. What's a negative divided by a negative? You're going to end up getting a positive. So 24 divided by 9. Well, let's grab a calculator for that. 24 divided by 9. 2.6 repeating. So 2 2/3. Got C coming down. So C is greater than or equal to 2.6 repeating, or 2 2/3. thirds. So how would I graph this one? I got to draw my number line out. I'm going to put 0 down. 2.6 repeating. That falls between 2 and 3. And because I have the line underneath my inequality symbol saying or equal to, I need to include that value. So I'm going to go a little bit beyond halfway. 2 and 3, halfway is right there. So I'm going to go a little bit past that. I'm going to fill in my circle. I'm going to go back to my solution and reread it to myself. C is greater than or equal to. So where are numbers that are greater than? They're to the right. So if you look at each one of these, we have y is greater than, x is greater than, v is greater than, c is greater than. These all came out to greater thans. Unfortunately, I probably should have thrown a lesson in there for you. But if you end up getting y is less than negative 12, instead of going right, you're just going to end up going to the left. All right? And this is how you solve inequalities. It's really, it's so much like chapter 1. If you solve equations, you're doing all the same things. The two major things you need to be aware of is you need to know how to graph them now. Graph your solutions once you have inequalities, because we have more than one answer, right? There's tons and tons of answers that will work in this inequality, because we just got to get numbers that are less than 9 in this case. Tons of answers, an infinite amount to be exact, okay? So know how to graph them, and then don't forget if you have to multiply or divide when using an inverse operation, if you multiply or divide by a negative, don't forget to flip your sign. Study hard and good luck on your upcoming test.